Sand dunes that hum. Mysterious trails made by rocks.
Here we go.
Creatures that glow in the dark. An ancient underground sea. Strange things happen when temperatures soar. And now, the mercury's climbing. This is the wilderness and the wildness in the Valley of Death. Death Valley. The name itself conjures an image of vast desolation. The lowest point in the Western Hemisphere. The driest place in the USA. The hottest temperature ever recorded on the continent. 134 degrees. It's a Martian landscape that hides some of the Earth's deepest secrets. Sand dunes that sing. A vast underground sea, home to one of the rarest fish on the planet. Plants that can lie dormant for years without water. Animals that need to drink no water at all. And one creature that survived for more than 350 million years. These features will all help answer a single burning question. What will happen if one of the hottest places on Earth gets just a few degrees hotter? When life at the limits of existence is pushed that little bit further. Telescope Peak, the roof of Death Valley. Over 11,000 feet above the desert floor. Every morning, it's the first place in this epic wilderness to feel the sun's rays. Yet it's snow-capped for some 8 months of the year. Park Superintendent J.T. Reynolds is up here for one last look and listen.
I mean, sometimes it's so quiet around here, your ears search for sound.
JT will soon retire. His last official journey through Death Valley will take him from the highest point to the lowest. And he'll touch on places that may never be the same. For the last decade, the temperature has been hotter, the causes and effects uncertain.
Climate change is real, whether people want to believe it or not. And national parks are places where that kind of research and questions can be answered.
Death Valley straddles Nevada and California. Over 3 million acres. Bigger than the entire state of Connecticut. From Telescope Peak, JT will spend a week on a journey down, stopping at places where climate change may become most evident. He'll finish at the lowest point in the park, Badwater Basin. As he and backcountry ranger Aaron Shander head down, the mercury will rise. and rise. Over 7,000 feet below Telescope Peak, there's no more snow. It's 70 degrees Fahrenheit. JT and Aaron near their first destination, Racetrack Playa. 5 square miles of mudflats, one of Death Valley's greatest mysteries. Boulders weighing up to 700 pounds, with long furrows behind them. Evidence that these huge stones have somehow moved across the racetrack surface.
The unbelievable theory is extraterrestrials will go and hang out at the grandstand. And then what they do is move rocks by whatever powers they have.
No human has ever seen these boulders actually move. But some scientists theorize that it happens during freak conditions, when intense winds push the rocks across a frozen land surface. With global temperatures on the rise, it seems that Death Valley is heating up. If freezing water is key to the unique conditions that allow these rocks to move, their days in motion may be limited. Less ice could mean less movement. The tracks may be fixed in time, eerie signposts to a changing climate. Death Valley is one of the driest places on Earth. But ice and water are critical in shaping this wilderness. Around 2 inches of rain fall every year in Death Valley. That's less than the average weekly rainfall in some parts of Hawaii. But when the heavens do open up over Death Valley, it's awe-inspiring. The baked desert surface absorbs little of the downpour. All that water channels into massive flash floods. It slices straight down. A single thunderstorm can deepen a slot canyon by several feet. And all that water can trigger an explosion of life. The desert plants seem almost spring-loaded. They wait for water, sometimes for years, then set off on a super-compressed life cycle. Some plants have only a few short weeks to germinate, grow, and reproduce.
Started her work in the 1960s.
Park botanist Michelle Slayton investigates the effect of global warming on these hardiest of plant species.
To me, the most fascinating thing there is life on the edge in an extreme environment like this. I'm really intrigued by how things can survive in this kind of habitat.
She knows the flora here is tough, but how tough?
So this plant, what's smart about it is that it puts most of its biomass, most of its body parts underground. and just goes dormant there, kind of like a hibernation, so to speak. So what we're seeing up here is in fact dead, but it's attached to a plant that's living down below, and that little piece that we saw behind us is probably part of the same plant.
These plants exist on the edge of life and death. Other plants have leaves that reflect sunlight and the ability to recycle water within their systems for years on end.
I would say that a plant like this, within its entire system right now, might be holding on to a half a cup of water and just recycling it through time. A couple rainfall events will keep this living for 20, 30 more years.
Death Valley is home to 16 plant species that live nowhere else on Earth.
Not much of anything growing up here right now.
To me, in this kind of environment, when you have very few plants, the ones that you see are speaking to you in a real clear way.
Something is killing them off, and exactly what is a mystery.
This whole hillside used to be covered with this dune grass, and now these are the remnants that we see. Let's say with climate change, we're expecting a 2-degree increase in temperature. The plants that are living here are already at their absolute maximum of what any living plant has experienced on Earth. I mean, the far outer limits of life. And so to push that even farther means that we would have to see evolution here that has never occurred, on planet Earth before.
Death in the valley comes from the sun. From the shifting sands. From the sheer vastness of this otherworldly desert. And the more heat, the more life is pushed. JT is now 1,000 feet above sea level. The temperature is 95 degrees. The lower they go, the drier and hotter it gets. Every 300 feet down drives the mercury up another degree. Relief arrives with the setting sun. As JT and Aaron make camp, the temperature begins to fall. With night comes wildlife that has developed specialized survival techniques. A kangaroo rat whose metabolism has adapted so much that it never needs to drink. And creatures tailor-made for specific extreme climates, from below freezing to way over 100 degrees Fahrenheit. Scorpions thrive in the harshest of habitats.
Death Valley is a hot spot for scorpion diversity. You have high elevations up to Telescope Peak, all the way down in the bottom, in these washes and playas, you have totally different habitats.
Biologist Matt Graham and his assistant use ultraviolet lights to hunt their highly camouflaged quarry.
And sometimes when you're lucky, you'll actually find them up in the bush.
Hi, here we go.
Got 'em?
Yeah.
Trapped by the UV light, a creature that once lived amongst the dinosaurs.
He just caught a little aerial insect, and now he's stinging it.
They feed at night on insects and each other.
Oh, this is neat. It's actually carrying away a smaller scorpion of a different species, which he's killed. So a lot of scorpions are cannibalistic.
There are cold desert scorpions and warm desert scorpions. Matt collects them to see how their diversity might change with even hotter temperatures.
Shape of the claws. Notice the smaller species.
Cold desert creatures are tough. Some can tolerate sub-zero temperatures and have a kind of biological antifreeze running through their veins. But what scientists don't know is whether or not they can take the heat. A temperature shift of just a few degrees could drastically change the mix of scorpion species.
You have about 1,500 to 1,600 species of described scorpions in the world. Totally different, yet they're all scorpions. Specifically, what I'm interested in is using scorpions at a genetic level to understand the bigger picture of how Earth history is played out.
In a desert transformed by climate change, scorpion diversity might be in trouble. Some species may decline. Others may thrive and inherit Death Valley. From Death Valley's highest point, J.T. Reynolds has traveled over 200 miles. Now he moves into the remote north of the park. The mercury's over 100 degrees and rising fast.
Now we're in an area called the Last Chance Range in Eureka Valley in the northwestern part of the park. So we have come quite a ways in a park as large as the state of Connecticut.
Here is one of Death Valley's most spectacular landmarks. This area is called Eureka Dunes. Death Valley is home to several dune fields. But the majestic mountains of the sand in Eureka Valley are one of the most environmentally sensitive and scientifically mysterious in the entire park.
This is kind of like a tabernacle. This is kind of like God's country. The earth talks to you here.
And it does, literally. Listen to this. The sound you're hearing is actually coming from within the dunes themselves. Just how these mountains of sand create this strange sound has baffled scientists for decades. Caltech engineers Natalie Vriend and Melanie Hunt are trying to find out how and why these dunes boom. That means a 2-hour hike to the top with over 200 pounds of equipment.
So we're carrying up equipment, heavy equipment, so it's rather hard to navigate.
To make matters worse, their work can only be done in summer. For a dune to boom, it should be over 120 feet tall. It must have a slope over 30 degrees. And it has to be hot, very hot. It's July in Death Valley. The mercury is peaking at 118. Extreme heat and winds that come from nowhere, some gusting to over 50 miles an hour. In the space of just a few minutes, the team finds itself climbing into a sandstorm. And it isn't just the air that's full of sand.
your ears, your mouth, your eyes, everywhere.
Finally, the wind ebbs. Now work can begin.
Line to the other side. So let's cover it well with sand again.
In order to understand what's making noise within the dune, they've got to be able to hear it.
So we're having a geophone here, which is basically simply a microphone that we're sticking into the ground.
They plot out 79 feet of the dune surface.
Are you ready?
Volunteers strike this block. Verind records how long it takes each of the geophones to detect the reverberation. The geophones hear waves trapped within the top layer of the dune, waves the human ear can't detect. Measuring these controlled waves might help them piece together the larger mystery. Next, the team needs to trigger its own boom.
Okay, let me arm the computer.
They slide downhill, creating a mini avalanche, simulating what happens in nature. In nature, wind creates the avalanches, destabilizing dune crests to the point where they collapse and trigger booms. Beneath the surface, the vibration moves through the sand. The dune picks up this vibration and amplifies it until the boom echoes out across Death Valley. Here is what their data suggests. The waves are trapped in the dry surface layer of the dune, between the air above and the firmer wet sand below. What we hear is some of that energy escaping. And the booming continues long after the initial disturbance that created it. The principle is not unlike that of a violin or cello.
When you're playing an instrument, you're putting energy into the instrument through the stringing. And here what we're doing is putting energy into the dune through the shearing on the top surface as we slide down.
And the booming is a single musical note, most often G, E, or F. The thicker the sand layer, the lower the note. On the far side of Eureka Dunes, J.T. Reynolds turns south towards the lowest point in Death Valley. The lowest point in the USA. Badwater. JT reaches sea level, then keeps descending. Soon, he's 20 feet below and still heading down. The reason he can go so low is that Death Valley isn't only a valley. It's a huge crack in the Earth's crust that's pulling apart faster than it can be filled in. Approaching Badwater from the south, geologist Brian Warnecke. He's a world-renowned expert on tectonics, which shape our planet.
The Earth has basically two modes. It either forms ocean basins, which are thousands of meters below sea level, or they form continents, which for the most part are above sea level. Places in continents that become below sea level are driven there by tectonic motions which pull the crust apart in a way that's faster than sediment can fill the hole.
The question, how rapid is Death Valley being pulled apart? To find out, Brian has set up a network of 35 global positioning stations throughout the Death Valley region. Each GPS transmitter is anchored 40 feet down into bedrock and specially cushioned to avoid any movement caused by the ground heating or cooling. The GPS stations take a measurement every 1/10 of a second, and the annual data they collect is accurate to 1/100th of an inch. The measurements show that Death Valley is on the move at a rapid geological rate, splitting farther apart 1/5 of an inch every year.
It's been truly revolutionary for geology to be able to watch the Earth in real time.
Within the Earth here, there's movement and there's life. Perhaps one of the strangest forms of life on our planet. Titus Canyon is a narrow gorge that funnels into Death Valley. In the 1920s, it was a lead mine. Now, it's the entrance to a labyrinthine cave system, one that may house a bizarre organism.
See that building at the end of that road?
Park scientist and caving expert David Eck leads biologist Diana Northup and caver Ken Ingham on a mission to investigate a mysterious find.
Right. This is the place to gear up.
To enter the cave system, the team must crawl through a shaft from the old mine.
Okay, are you going through on your back or your stomach?
I go on just my side. Yeah.
Okay, coming up.
Through if you want.
The cave is really a series of cracks and chasms, 3 feet wide in places and more than 200 feet deep.
Watch the walls for aragonite.
Okay. Am I clear, David?
Yes.
Okay.
At its base,
Ooh, look at those aragonite bushes. Wow.
a crystal-lined chamber few humans have ever seen. These fragile and beautiful crystals grow here undisturbed, as they have for centuries. But this is not the object of this expedition. Months ago, while exploring this cave system, David Eck discovered some strange blotches on the walls. Diana Northup believes the blotches could be evidence of a unique life form with amazing qualities. She searches for organisms that don't need sunlight to survive. Microbes that eat rock.
They're like little engineers. They're mining the rock walls for substances that they can eat.
Diana heats her equipment to burn off bacteria that would otherwise contaminate her samples.
It's a way to sterilize and make sure you're only culturing stuff from up there, not from other places. Okay? So
she takes samples of the rock surface, and she hopes the microbes living in it.
when you look at the rock walls, you don't really think that they could be alive, that there's all kinds of things that live here.
A scanning electron microscope magnifies the samples over 1,000 times. The results are positive, but puzzling. These star structures hint that the microbes are present. But it may take years for Diana to identify exactly what species.
So the caves are really revealing mysteries to us. We're finding novel species, ones that may date back millions of years, that have lived a very slow existence in caves.
Farther and farther down, J.T. Reynolds nears the floor of Death Valley's desert wilderness. At 282 feet below sea level, he enters the hottest zone of them all, Badwater Flats. The lowest point on the continent, and the hottest place in the USA.
You know, in 1913, it reached 134 here in the park, and that's a record. You've got 128, 29 that we have experienced, at least since I've been here.
Surprising, then, that this area is far from dry. In places, water seeps up from a giant underground reservoir. But this is no place to quench your thirst. By the time this water reaches the surface, it's undrinkable, loaded with salt. Water here is twice as salty as it is in the ocean. Rainwater runoff pools here as well. As it evaporates, it leaves salt crystals. But no matter how hot the temperature, the springs never dry up. Nearly 50 times more water evaporates from Death Valley than ever falls here as rain. JT is at Death Valley's deepest point. Now he's about to go even deeper, in search of that underground water. They drive about 60 miles east from Badwater. His destination? A remote chasm in a rocky hillside. It's an opening to a vast cave system. JT's here to help with a dangerous, rarely attempted cave dive, under the supervision of caving expert David Eck.
Okay, get ready to lower! Some people explore in the canyons or the mountains, but there's an underground Death Valley too, which isn't as well known. And there's mysteries all throughout the park, including in the caves here. There's that first ledge.
This is the entrance to one of Death Valley's least understood ecosystems. To protect it, they must first document what's here. The scientists aren't certain what they'll find. No one's been down here for years. Their mission, to explore Death Valley's underwater cave system.
Lower away.
No one knows its size, its depth.
It's a really stiff rope. You're not going to go fast.
Just reaching the starting point for the dive requires an incredible effort. And it's risky.
Right heading.
Slack! All the way!
On the bottom! Plane! Off belay! What's up, y'all?
Team members lower themselves through vertical shafts, deeper and deeper into the cave system.
Yeah, babe, you're good. It's cool, man. I'm gonna head
Try and pull the rope down.
Finally, they reach the water.
Okay, that side's on. That's good. You got things. These right here? Top. No, it's just. Yes.
Which fins smell? Black ones?
They check and triple check gear before the divers submerge.
You got it. You got the nose line, no deeper than 1/3.
Cave diving is one of the most dangerous pursuits on Earth.
Tom, you got 5?
If anything goes wrong underwater, the chance of survival is limited. Divers can become disoriented and lose their way, running out of air with no chance of surfacing. They find a crystal clear window to a world few have ever seen. It's been said that more people have walked on the moon than have entered this water. No one knows the size of this system. It's at least 150 feet deep. They analyzed the water. Its temperature is a steamy 92 degrees Fahrenheit. They measure acidity, clarity, and oxygen levels. It's perfect drinking water. And there's no doubt it's part of a bigger reservoir. An underground reservoir so immense, it stretches well beyond the park's boundary and towards Las Vegas, a city whose booming population may pose a threat. Here, officials need water and want to tap underground supplies. The concern is that may cause the level of Death Valley's groundwater to drop.
If they're going to continue to build homes and increase the populations in the desert, you're going to need water. Well, someone might say, well, maybe when do we stop? And when do we start looking at something that's called sustainability? Why should we, our generation, be so greedy and take the water from future generations?
And if this water supply itself is threatened, so too is a unique animal that lives in it, already one of the rarest species on the planet. There's another cave entrance to Death Valley's subterranean reservoir. It's called Devil's Hole. It's fenced off and swept by surveillance cameras. This is the reason. The Devil's Hole pupfish, one of the rarest fish known to man. A year ago, they counted only 92 pupfish in Devil's Hole. Today, park fish biologist Mike Bauer is leading a dive survey to find out how many are left. They're on the brink of extinction, and no one knows why. Only one team of highly trained cave divers is ever allowed to enter Devil's Hole. The team's ready, but achieving their goal will not be easy. First, a precarious climb down Devil's Hole in full dive gear to the water's edge. then into this underwater chasm whose depth has never been measured. The dive team must find and film a fish that, fully grown, is only 1 inch long. It's a game of hide and seek, a fathomless aquatic hole, and hopefully a population of tiny fish. Then, an extraordinary sight. One of the rarest fish on the planet in clear view. This is precious scientific footage. There's no doubt this year the numbers are up. The dive team counts over 100 pupfish living under the desert. But topside, Mike knows there's no cause for celebration.
9 on level 3, and 7 on level 2.
We have learned through experience to guard our emotions to some extent because we know very little about the initial causes of why this population started to decline.
The Devil's Hole pupfish has endured for tens of thousands of years in the most extreme circumstances. Now, it is not only threatened by communities looking to suck up its water, but scientists suspect global warming could write the next chapter in this epic survival story.
The Devil's Hole pupfish lives very near its physiological limit for water temperature already, with a background water temperature of nearly 33.5 degrees centigrade. And so any minor departures from that background could be incredibly important in terms of Devil's Hole pupfish abundance and their ability to reproduce.
The Devil's Hole pupfish may be our canary in a coal mine, a tiny creature that can tell us so much about how our world might look in the future. We ignore the smallest and most vulnerable among us at our own risk. In their fate may lie our own.
The National Park Service's mission is to preserve and protect for future generations. Now, will we ever learn? I guess that's the key point here.
On his last journey as superintendent, J.T. Reynolds has traveled over 2 miles down towards the center of the Earth.
This particular trip has allowed me to cover as much as the park as I can in one fell swoop. This is one rich resource in terms of what people can learn and what they can find. There's a lot of mysteries here.
His journey has spanned nearly 100 degrees Fahrenheit. From the snow-capped Telescope Peak to a valley floor that slowly splits. And beyond, to mysteries, marvels, and even miracles. Boulders that move unseen across Racetrack Playa. Sand dunes that sing. Plants that bloom only once every few years. The last unlikely refuge of an endangered desert fish. These wonders rely on predictable, though often searing, temperatures. JT knows an increase of just a few degrees could change everything. America has many wild spaces. But perhaps this place of extremes is the one where our planet speaks to us most clearly. Perhaps it's from this valley